In chemistry, we also often have to deal with very large and very small numbers, and we can easily do that using scientific notation. For example, 1200 can be written as 1.2 times 1,000, which can be written as 1.2 times 10 times 10 times 10. Something multiplied by itself 3 times is that item cubed. So we can write 1200 as 1.2 times 10 to the third power. In a similar process, we can take 0.035 and write that as 3.5 divided by 100, or we can multiply by 1/10 and 1/10. Okay, we recall that anything raised to the negative 1 power corresponds to 1 over that item. So we can write 1 over 10 as 10 to the minus 1. If we do that twice, that's going to correspond to 10 to the minus 2. Alright, so we can write 3.5 times 1/10 times 1/10 as 3.5 times 10 to the minus 2 power. Any number expressed in scientific notation has 2 different parts. So if we look at 3.5 times 10 to the minus 2, the first part is our coefficient. It's a number from 1 up to, but not including 10. So 1 to 9 point whatever. The exponent is going to be this power of 10 multiplier. Now, we can easily convert back and forth between decimal and scientific notation, keeping in mind these rules. Numbers that are larger than 1 have positive exponents. For example, 1200 is going to have a positive 3. Numbers that are smaller than 1 have negative exponents, as we see in our second example. And the exponent indicates the number of places to move the decimal point. For example, in the number 1200, it's not written, but our decimal point is in this location here. We'd have to move our decimal point 3 spaces to get it to a number between 1 and 10, and that corresponds to our exponent power 3. For 0.035, we would have to move the decimal point 2 spaces to get our coefficient number between 1 and 10. Okay, so we can practice a little bit. The number 451 would have the decimal point in this location. We'd have to move it 2 spaces to get it between the 4 and the 5, so 4.51 is between 1 and 10. So our number is 4.51 times 10 to the second power. The negative exponent means that we're going to have to move the decimal point in this other direction to get a number less than 1. So we're going to have to add some zeros here in order to make sense of this number. So the decimal number is 0.000307. And note, in each of these cases, I was careful to make sure that I preserved the significant figures when I did the conversion. 93 million, or 9.3 times 10 to the 7th. Okay, if we move the decimal point 1 place, we'll have 93. We're going to be moving it to the right so that we get a number larger than 1. So that's 1, 2, 3, 4, 5, 6, 7. 93 million. If you're writing large numbers, sometimes it's easier to read if you kind of group the zeros in groups of 3. This number, we'd have to move the decimal point 2 spaces to get between the 6 and the 4. So we have not 2 spaces. Let's be careful here. 1, 2, 3 spaces. 6.4 times 10 to the minus 3. Okay, and again I preserve the sig figs. 2 sig figs here. Remember, these leading zeros don't count as sig figs, and we have 2 sig figs in our resulting answer. If we use sig figs in calculations, we have to be mindful of some rules, because we need to appreciate that the calculation is going to be limited by the worst measurement in that calculation, and we must report the answer appropriately so that we know how reliable the result is. Okay, the consumer of that result needs to know what level of uncertainty is associated with that result. So for multiplication and division, we look at all the numbers that go into the calculation, and we report the answer with the same number of sig figs as there are in the measurement with the fewest sig figs. The number with the fewest sig figs is our worst measurement for multiplication and division. For addition and subtraction, our worst measurement is the one that has the least number of decimal places. So we're going to limit our result to the first uncertain decimal place. Now, in these calculations, at the end, we never round until we get to the end, but once we get to rounding, we're just going to use simple rounding rules. If the first digit to be discarded is 5 or greater, we add 1 to the last sig fig. Otherwise, we just discard all of those numbers. And some examples. If we do this calculation, we would first note that as far as our units, the units of meters cancel out. So we can put a reminder that units cancel the same as numbers. Meaning that, for example, if we had 3 over 3, that's going to be equal to 1. And by the same token, meters divided by meters, as we have in this example, is going to be equal to 1, and the 2-meter units cancel out. So overall, our units are going to be inches per second. Now, to get our number, we just do the operation that's indicated. So both these numbers are in the numerator, so we multiply these two numbers together. Everything on the top is multiplied together. Everything on the bottom indicates division, dividing that number by everything that's in the bottom. So we put these numbers into our calculator, and we have 1.180273 times 10 to the 10th power. So this is our calculator answer. Our calculator does not know how to handle sig figs. That's up to us. So we look at our calculator answer, and we're going to have to round that off to an appropriate number of sig figs. Multiplication division, our rule is to use the number with the least number of sig figs. We look at this number. All of these digits are between 1 and 9, so they all are significant. This first number has 1, 2, 3, 4, 5 sig figs in it. The second number has 4 sig figs. So we need to round our answer out to 4 significant figures. So we count 1, 2, 3, 4. I like to draw a slash to remind myself that this is my limit as far as significant figures. I look at the next number. It's a 2, that's less than 5, so I just drop all of those numbers and rewrite my answer. 1.180 times 10 to the 10th, and my units are inches per second. The next two problems don't have associated units, but we'll just assume that they are measured numbers. If we look at these numbers, we see that we have our last uncertain decimal place is the tenths, okay, 1 over 10. This is the tenths, hundredths, thousandths, 1 over 10,000. This goes out to the thousandths place, and this goes out to the hundredths place. So our first uncertain decimal place here is going to be in the tenths. So if we take all these numbers and add them together, we would get our calculator answer. And I get 52.436. I'm going to try that again just to make sure that I didn't mess up. 22 plus 6.8050 plus 15.071 plus 8.56. Okay, 52.436. Okay, our first uncertain decimal place is in the tenths, so we're going to drop all the numbers beginning with 3 and we round down. So this is 52.4. This final problem is a combination, so we're going to have to be careful here. We're going to go through a number of steps. So let's add all these together and see how the result of this addition problem should be displayed. So we have 0.8 plus 12. And we get 18.965. A quick sanity check here. Okay, 18.965. Okay, this number is to be divided by 4.0. And we can get our calculator answer. 4.74125. Alright, now we'll go back and worry about significant figures. Three sig figs in the denominator. Our numerator is determined by this addition result, and in our result of our addition, we see this is the tenths. This goes out to the thousandths, the hundredths, the hundredths. Okay, so we need to round to the tenths. That means that our result here on the top should be correctly expressed with 3 sig figs. 3 sig figs, 3 sig figs. Our answer should be expressed with 3 sig figs. So our final correctly expressed answer is 4.74.